Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. In this video, we'll explore throttle-by-wire, steer-by-wire, brake-by-wire, and examine the backup and fail-safe design used in each of them. Brake-by-wire systems have finally entered practical use. To be precise, it's a dry brake-by-wire system. As will be explained in detail, if there's a dry system, there is naturally a wet one as well. This system completely eliminates the physical connection between the driver's right foot and the brake pads. What will it bring to drivers and automakers, and what will it take away? Prior to by-wire systems, a traditional mechanical cable connected the accelerator pedal directly to the throttle valve. When the driver depresses the accelerator pedal, the cable is pulled, rotating the linkage. Then the throttle valve opens. In contrast, throttle-by-wire systems replace the mechanical cable with electrical wiring, routing the signal from the accelerator pedal to the throttle valve via the engine control unit. When the driver depresses the accelerator pedal, the accelerator position sensor detects its position and operation velocity, converts this data into an electrical signal, and transmits it to the control unit. The control unit processes this signal to determine the driver's intent, factoring in engine speed, the current gear, and vehicle speed, to calculate the optimal opening. Based on this calculation, the control unit commands the throttle motor to open the valve. The first vehicle to adopt this system was the BMW 750i, back in 1987. So, what are the advantages of throttle-by-wire systems? There are numerous advantages to being able to control the throttle valve independent of the driver's input. In step-type ATs and DCTs, engine speed must be reduced during upshifts and increased during downshifts. Prior to by-wire systems, reducing engine torque required retarding ignition timing or cutting fuel injection during upshifts. And of course, downshift rev matching was completely out of the question. Cruise control, traction control, and ESC, electronic stability control, also require engine torque control. In the good old days, cruise control systems relied on a diaphragm actuator, powered by manifold vacuum, to pull the throttle cable and increase engine speed. While neither traction control nor ESC even existed at the time. To manage engine warm-up, changes in electrical load, and air conditioner load, the idle speed needs to be finely controlled. Back then, idle speed was controlled using an air bypass passage that allowed air to flow around the closed throttle valve. However, by-wire systems made this mechanism unnecessary. Because the throttle valve can be controlled to smooth out abrupt driver inputs, it is also beneficial for emissions control. In a turbocharged engine, even when the accelerator pedal is released, the throttle valve remains open. This maintains the turbine speed, and as a result, reduces turbo lag. By incorporating a drive mode feature, the throttle valve can open more gradually in normal mode, and more aggressively in sport mode in response to the same driver input, creating the illusion of improved performance. While throttle-by-wire offers many advantages, what are its drawbacks? It's hard to think of any. If anything, the only drawback is that some MT enthusiasts complain that throttle valve response is no longer perfectly linear with accelerator pedal input. With virtually no drawbacks and numerous advantages, the throttle-by-wire system spread rapidly throughout the 1990s and 2000s. Today, this system is used in almost every engine. In mechanical steering systems, the steering wheel and the steering rack are connected via a steering shaft and gears. In electric power steering systems, the steering is assisted by an electric motor, but the steering wheel and the steering rack remain mechanically connected. In steer-by-wire systems, The steering shaft is eliminated, and the steering wheel and the steering rack are no longer mechanically connected. The driver's steering wheel input and steering speed are detected by a steering sensor. The steering control unit calculates the appropriate front wheel angle and steering rate based on the sensor signals and drives the steering motor. Simultaneously, the reaction force motor generates torque in the opposite direction of operation, providing the driver with steering feedback. Drivers sense road conditions and tire traction through this resistance. But in this system, that feedback is artificially generated. This system offers three main advantages. The first is that the front wheels can be steered independently of the driver's input. For example, on the highway, the steering gear ratio can be increased to give the driver a greater sense of stability. When parking, the gear ratio is reduced, allowing the front wheels to steer more to ease the driver's workload. The second advantage is that it filters kickback from the road surface. In mechanical systems, when tires encounter bumps, every harsh impact is transmitted directly to the steering wheel. This system, however, isolates those harsh shocks, then delivers only the necessary road feedback to the steering wheel, which is artificially generated by the reaction motor. The third advantage is that the steering shaft no longer needs to pass through the engine compartment. This gives engineers much greater freedom in packaging and component layout, making vehicle design considerably easier. However, this provides no benefit to the driver. The world's first steer-by-wire system was introduced in the Infiniti Q50 back in 2014. Since then, while we have seen it in models like the Lexus RZ and Tesla Cybertruck, the technology has not seen widespread adoption. To be precise, although several automakers have announced plans to introduce steer-by-wire, we rarely see follow-up news confirming its actual mass production. Exactly, the reality is, it is simply not in high demand. Compared to throttle-by-wire, which offers clear and immense benefits, the advantages of steer-by-wire are highly limited. On top of that, the extreme level of redundancy required causes manufacturing costs to skyrocket. To put it bluntly, steer-by-wire is nothing more than a marketing gimmick to showcase a manufacturer's technological vanity. Finally, the Chinese automaker, Chery, has commercialized this dry brake-by-wire system in its Exceed EX7. In addition, brake supplier, Brembo, announced that it has begun mass production of brake-by-wire systems for automakers. However, the specific automaker has not been identified. These are dry brake-by-wire systems, where the brake pedal and calipers are completely disconnected physically. Brake suppliers have proposed this system for years, and now, it has finally come to fruition. First, we will examine the structure and operating principles of traditional hydraulic, wet-by-wire, and dry-by-wire brake systems. In a hydraulic brake system, the movement of the brake pedal is converted into hydraulic pressure by the master cylinder. This hydraulic pressure then moves the pistons in the brake calipers, causing the brake pads to clamp the brake rotors. There are two types of wet brake-by-wire systems. The first is the accumulator type. A hydraulic pump continuously generates brake fluid pressure and stores it in the accumulator. The driver's brake pedal input is detected by a brake pedal sensor, which sends a signal to the brake control unit. The control unit calculates the optimum braking force and opens the solenoid valves to apply hydraulic pressure from the accumulator to the brake calipers. The second is the electric servo type. The pedal sensor detects the driver's input, and the control unit drives an electric motor to push the master cylinder piston through a ball screw. Wet brake-by-wire systems are essential for hybrids and battery electric vehicles, which require coordinated control of regenerative and hydraulic braking. Therefore, these systems have a long history. The accumulator type was introduced in the 1997 Toyota Prius, while the electric servo type was adopted by Volkswagen in 2013. Although electronically controlled, Both systems still remain hydraulically connected between the pedal and the calipers. Dry brake-by-wire systems eliminate hydraulic lines altogether. The electric motor, activated by signals from the control unit, converts its rotational motion into linear motion via a ball screw, pushing the piston to apply the brake pads. What benefits does this offer to the driver? The response time is cut from approximately 150 milliseconds in a wet system to between 80 and 100 milliseconds in a dry system. In other words, when the driver steps on the pedal, a wet system responds in about 0.15 seconds, whereas a dry system takes just 0.08 to 0.1 seconds. At a speed of 100 kilometers per hour, this difference reduces the stopping distance by 1.67 meters. This seems to offer some practical benefits, at least compared to steer-by-wire. Another benefit is that regular brake fluid replacement is no longer necessary. In this section, we will consider how safe and reassuring by-wire systems actually are. These systems incorporate various measures to enhance driver safety and reassurance, including redundancy, fault tolerance, backup systems, and fail-safe functions. Let's take a look at signal multiplexing, using a throttle-by-wire system as an example. The accelerator pedal sensor incorporates two internal sensors, each outputting a different signal value. As the pedal is depressed, the voltage of one signal increases, while the other decreases. The control unit continuously monitors both signals and detects a fault if they become inconsistent. However, the system will continue to operate using the remaining signal, while limiting functionality to allow the vehicle to be driven safely to a repair shop. The throttle-by-wire system is also equipped with fail-safe functions to handle unexpected failures. The throttle valve incorporates a return spring, which forces the valve closed if the system fails while it is open. Furthermore, because the throttle valve shaft is mounted slightly off-center, engine vacuum continuously exerts a closing force on the valve. In this way, even if the system loses electrical power completely, mechanical and physical forces will force the valve closed, preventing the worst-case scenario of unintended acceleration. Nissan's steer-by-wire system is equipped with a mechanical backup. Although it is a steer-by-wire system, it retains a physical steering shaft with an electromagnetic clutch. When the system is off, the clutch is engaged by spring force. When the system is turned on, the clutch is disengaged by an electromagnet, mechanically disconnecting the steering wheel from the steering rack and allowing it to operate as a full steer-by-wire system. If electrical power is lost, the clutch engages by spring force, allowing the steering to function as a heavy manual system without any power assistance. Although steering effort becomes extremely high, the vehicle remains steerable, allowing the driver to reach a repair shop through sheer physical effort. In addition, this world's first steer-by-wire system is equipped with 3 independent control units to safeguard against potential failures. Incidentally, early throttle-by-wire systems also used accelerator pedal sensors with 3 output signals. Apparently, when developing a world's first system, even double redundancy isn't enough to give engineers peace of mind. The Lexus system is equipped with a backup power supply to safeguard against a total loss of electrical power. Tesla, on the other hand, utilizes 2 steering motors, with one serving as a backup. Unlike Nissan's approach, these systems completely eliminate the mechanical backup. If the system were to fail entirely, the driver would have no choice but to call for roadside assistance. So, what about wet brake-by-wire systems? In an accumulator type, valve 3 shown in the diagram remains open when the system is off. When the system is turned on, electrical power is supplied to close the valve and isolate the hydraulic circuit. In the event of a power loss, the valve automatically opens, hydraulically connecting the master cylinder to the brake calipers. The driver's pedal input is then converted into hydraulic pressure to actuate the brakes. In an electric servo type, If electrical power is lost, the driver's pedal input directly pushes the master cylinder piston, generating the hydraulic pressure needed to operate the brakes. In both systems, even in a worst-case scenario, a complete loss of braking is avoided, though much greater pedal effort is required. By contrast, dry brake-by-wire systems lack this physical backup entirely. However, they are designed with an exceptionally high level of electrical redundancy. In addition to the high-voltage battery used for brake actuation, the 12-volt battery powering the control units is equipped with a dedicated backup. The system also employs dual control units and 2 independent communication channels. Brembo has gone a step further, announcing that each individual brake caliper features its own dedicated control unit. Brake calipers with integrated motors and electronics are designed to withstand intense vibration, extreme temperatures, mud, and water, and are undoubtedly assembled to rigorous quality standards. At least, during the early years of a vehicle's life, or while its mileage remains low, the probability of this system causing a major accident is vanishingly small. In other words, it can be considered safe. But that is not at the heart of the problem. Do you remember the Mercedes-Benz SBC Sensotronic brake control recall that occurred in the early 2000s? This accumulator-type wet brake-by-wire system was introduced on the R230 generation SL class, launched in 2001, and the W211 generation E class, launched in 2002. Plagued by reliability issues, the system ultimately led to a massive recall, affecting approximately 2 million vehicles. Interestingly, while several rear-end collisions and crashes into fences were reported, there are no records of any fatal or major accidents. Yes, what customers truly demand is not just safety, but peace of mind. This is entirely different from a check engine light that occasionally comes on for no apparent reason. Who would feel comfortable driving a car to a repair shop with the brake warning light illuminated? This massive recall is estimated to have cost Mercedes-Benz several hundred million euros. One can only hope that neither Chery nor the automakers adopting Brembo's system will suffer the same fate. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.